Hi guys, so my name is Rohit Sharma, and I'm going to introduce basics and principles of machine learning. And I'm going to talk about this course as to how this is going to unfold in the coming weeks and months. And this is a little bit about me. I've been an author, entrepreneur, and mostly a technologist. Essentially, I have fun working with software and firmware, and I've done that all my life. I've worked for companies like TI, Magma, Apache, Cadence, Paripath, and AITS. And these days, I'm working for a company that I founded back in 2018, and that company essentially is we have the entire framework library and entire platform for bringing complex models to tiny boards like the one you see in my hand. So this is a microcontroller with quite a few sensors in it, and it has a pretty basic processor of about 60 megahertz, with a RAM size of about 192 kilobytes, and a flash, which is like a disk, is about 1 megabyte. So, if you compare that to your cell phone, in every compute aspect of either, ranging from CPU to RAM to flash size, it's at least 3 orders behind. So collectively, it's 10 or more order behind, and you're looking at a board which is like a machine of 80s. And so we are bringing the models of today onto these boards, primarily because these boards are everywhere, and there are 300 of those as we speak. And just last year alone, over 30 billion were produced in 2020. So the scalability of this problem is large. And if you're sitting, in your house, there is a microcontroller in your DSLR, in your toaster, in your fridge, in your TV. And if you're sitting in your car, there are probably 50 of these in your car. So they are part of our daily life without us knowing, and it's exciting to work on something like that on a daily basis. So this is what we do, what I do on a daily basis. The company's name is AI Technology and Systems, and my personal handles, social handles, you can connect with me on LinkedIn, Medium, that I write quite a bit about AI. I have a GitHub account that I tend to put my open source IP, and there is a deep learning framework, the entire framework and a library there, designed for boards like these. You can look at that, and you can message me on any of these platforms if you have a question inside or outside of class. And like Professor Glenn said, I have written a couple of books. This is one of the books that I authored back in 2018, I believe. And this is an application of machine learning in design automation. So this has been a bestseller in its own category. I wrote another book on BRSI back in 2014, and that was a good bestseller in its own category as well. So this is my introduction. Like I said, I'm generally happy and passionate about the software and the technologies. So with that, let's move on. If you have question, feel free to raise your hand, and we'll address the question in the middle of the presentation. Remember, this is for you. I'm going to go through um, parts of the coursework as to what we're going to cover, what we're going to talk. And most of that would come from my experience working with companies and agencies like NASA and Air Force that we continue to work with, and CSIR, looking at the AI technology from the industrial and real life point of view as to how these techniques, data, algorithms, and frameworks are applied and how they're used. So this is an 8-week course, and we're going to cover from basics to advanced algorithms. We would like to cover until GAN, and we'll introduce a popular framework like TensorFlow and PyTorch. TensorFlow is more popular and used than PyTorch. TensorFlow is typically more popular in the production flows, and PyTorch is more popular with the research community. We are fine with either one of those. We'll cover detailed applied theory as to from a bit of mathematics, including statistics and linear algebra, not too much into it, but we'll cover the topics so that when we are discussing some of these networks and we go back to that discussion, we understand the entire theory from mathematics all the way to the software and the code, so that if you, in case you end up changing some of the parameters, you have the logic behind that and reasoning behind as to why and how that would affect the accuracy or the cost function or things like that. And we'll work on 2 projects, midterm project and final project. And we'll use tools like GitHub, Jupyter Notebook, Colab, and of course, lots and lots of discussions. And this is the division of the grade. And 10% would be on the homework, 25% on the quiz. We'll give 10% for midterm project, 20% on final project, and 30% on the final exam, and 5% for the participation, with a total of 100. And most of this course will be covered using slides that I would bring, and I would also bring handouts in case you have more questions and would like to go deeper into some of those topics.